All right, so 2.8. Starting this one, inequalities. We're going to deal with these symbols here, and we're going to check. We're going to check whether the addition of equality rule works from 2.1 and the multiplication rule for equality from 2.2, if this works for these guys as well. All right, another thing, as we get into some of the word problems in this section, this whole concept of English translating it into math symbols, because sometimes we sort of say something backwards in English. Like this, it says x is at least 30. When you say is at least, what you really are talking about is that x is greater than or equal to 30. So if you say, again, anybody been to Disneyland, there's a sign that says you must be at least 48 inches tall to ride this ride. Right? So if you're exactly 48, you can do it. If you're 50 inches, you can do it. 46, I don't think so. Then you take the child, right, and then you kind of like hold him up a little bit here to get him.
I did that to Kirby, the speaker. I had to step on my foot.
There you go. Okay, so x is at most 20. That means the symbol for it is actually less than or equal to. So there's a little change there. And that is inside your textbook here. Anybody know which page number? 155 is just checking here. Is that right? 156? I just don't see it.
Right there.
Okay, it doesn't look like that, right? It's just a little different. All right. Okay, I got it somewhere. I don't know where I got it from. I'm going to try to find it now. Yeah, okay. It's a little bit different. So I don't know where I got this from. Okay. We'll get to the addition property, though. Let's take a look at this here. The addition property of inequalities. Remember this little symbol. And it works for all the other ones, too. But the question, yeah, this was on page 155 for sure. I don't know where I got the other stuff from. All right. All right, let's go back to pre-algebra. And again, I'm making stuff up from my mind. That's it, okay? So the question is this. Everybody agreed 3 is less than 5? Let's add the same number to both sides, and I just want to see if I can keep the same symbol. Cool. If I add 4 to both sides, can I still keep the same symbol? Yeah, because one's 7, one's 9, and that is true. Is that right?
Yep.
Okay. How about if I were going to add a negative number? Just out of curiosity. How about if I had this? 3 is less than 5, and I'm going to add a negative 10 to both sides. Does my inequality change?
Yes.
3 minus 10 is a negative 7. 5 minus 10 is a negative 5.
No.
It doesn't change. Huh, interesting. Okay. So if I were to add a positive number, add a negative number, the addition property says I still keep everything exactly the same, just like my equal sign. And again, I'm getting these rules from some examples from pre-algebra. We good? All right. So let's just let's see. Let's try some. The easy kind, and then we'll get into more difficult kind. All right, so let's go for it here. So for number 1, x minus 6 is less than 9. What should we do to get x by itself? Add 6 to both sides. Yep, on that one and that one. And the minus 6 and the positive 6 go away, so I get x is less than 15. We good there? I don't like that. Okay, so real quickly here, let's go to this here. We're going to have to graph it as well. And then we're going to do something called interval notation. It's something I'm going to teach you guys. Something that's not in the textbook here. And like I said before, all the test banks that I found, they do it the new way. There's no test banks that do it the old way. So we all have to upgrade ourselves. Okay, let's go for it. So graphing this, we're going to find 15. And remember back way in high school, we looked at something called closed dots and open dots. Remember that a long time ago? So if it was a less than symbol, it used to be an open dot. And what you would do, since it's x less than 15, you would shade to the left, because you're looking at something that's lower than 15 as their answer to this. So first of all, let's talk about the answer first. So that means any number that's less than 15 is going to work for this problem. So that means if I take, let's say 12. 12 minus 6, that's going to be a 6, right? And 6 is less than 9. Or 10. 10 minus 6 is 4, and that 4 will be less than 9. We good? This is the solution to this problem here. Any numbers that are less than 15 will work for that solution. Okay. Here's the way I want you guys to write the answer. This is called interval notation. So if it goes off to the left forever, I'm going to start off at parenthesis, negative infinity, comma. So what we do is we start off to the left. On the number line, we're going to go all the way up to 15. And if there's an open dot here, what we're going to do, we're going to put in a parenthesis. If there's a closed dot, we're going to do something else, okay? So, real quick here, if you think about it, any open dots you have, they're going to be in terms of parentheses. Any closed dots, they're going to be in terms of brackets. That's what we're going to use. Cool. So, that's it right there, as long as we can get those two concepts down. Open dots are parentheses, closed dots are brackets. So open dot really means we're not including the 15. 15 is not part of our answer. Anything below 15 is. So 14.9, we're good. 14.9999999, we're still good. 15, not good. Okay, good there? Bracket, if it's a closed dot or a bracket, that means you are including that number as well. So let's take a look at this here. X plus 3 is less than or equal to negative 4. And that bracket is from the equal to part. So what should we do to solve 2? Subtract 3 is good. Subtract 3. I get x is less than or equal to negative 7. Okay, so as far as, let me just check one more time here. As far as homework is concerned, they want this as the answer. And as far as online homework, they'll want this as the answer. Sometimes they ask for a graph. So if they're looking for a graph, then it means you want a closed dot like this, because it's a less than or equal to. This little equal to piece means I'm going to include the negative 7. And real quick here, off to the left or off to the right?
To the left.
To the left. You got x less than or equal to negative 7. So there it is. Okay, and you tell me, how should we write our final answer, the one we're going to use on our test on Tuesday? So, hold on, starting off at negative infinity. Negative infinity. Now with infinity or negative infinity, you're always going to use a parenthesis. We're good? Write it down somewhere. So with infinity or negative infinity, you're always going to have parentheses. Comma. And then when you go up to negative 7, then you're going to use that little bracket.
How much negative infinity on the 15? Because 15, keep going left, you're just going to go into the negatives forever.
Yeah, so this little, the negative infinity means you just keep on going forever this way.
But if the infinity was on the other side, it always be without a negative sign.
We'll get there. Yeah, but it won't be. Yeah, it will be without a negative sign. Okay, so slowly making our way through this. Everybody okay with that? Where the distinction is? Infinity symbol. So this little part right here, before the comma, it's kind of like one piece, and then after the comma, there's another piece. It's almost like this is your starting point. This is your ending point. So again, your starting point, and then your ending point here. Okay, let's take a look at the next rule. How about the multiplication property for inequalities? And before we look at the highlighted section here, all the good stuff here, let's do some examples here. So everybody okay with 3 less than 5 again? How about this time I'm going to multiply through by a positive number? So my question really, again from pre-algebra, do I keep my same inequality? Say 3 times 4 is 12. That's going to be 20. Everybody good there?
Okay.
12 is still less than 20. And if I multiplied by 10, that would be fine too, because that would be 30 and 50, right? And 30 would still be less than 50. Seems like it works. all the time. I'm just giving one example. Okay. How about another one here? How about if I multiplied by a negative 4 instead of a positive 4? Just want to see what happens. 3 times negative 4? Negative 12. 5 times negative 4? Ooh, that's weird. Yes. From pre-algebra, we just learned this little rule. Okay, so if we were to multiply, in a sense, or divide, right? Because multiplication and division, same thing. If we were to multiply or divide by a negative, we have to switch this inequality. And again, it works in pre-algebra, therefore it has to work in algebra. Okay, so here's a little rule. It is on page, anybody? 156. There's our rule there. So if you want to see it, again, the English sentence for it is multiplying both sides by an inequality, or of an inequality, by a negative number reverses the sense of the inequality. That's kind of in words here. Okay, let's do a few problems. I think once we do a few problems, it'll make sense here. Alright, solve the inequality. 5a is greater than 25. What should we do to solve for a? Divide by 5. Yep, we're dividing through by a positive 5, so we're cool like that. A is greater than 5. Can you graph it? And after graphing it, can you put it into interval notation? Alright. So looks like open dot first for the graph, is that right?
Yeah.
Since a is greater than 5, now we're going to go off to the right. Alright, in this case, we're going to have to start off with, and notice the interval notation, they always start off with a low number and you're always going to the high number. So you're going to start off with a parenthesis because of the open dot at 5. And then since you're going off to the right, you're going to go off to positive infinity. Still a little parenthesis next to the infinity symbol. Okay, everybody good there? Good, that's the new stuff.
So when it's to the right, the infinity sign comes up.
Yeah, if it goes up to the right forever, that means the infinity symbol's on the right. If it goes down to the left forever, the infinity symbol's on the left with the negative. Cool, alright. Dividing through by negative 7 on number 4. And then this alarm goes off on your head, is that right? Okay, the little symbol that the book uses to show that the inequality has changed is this little sort of spiraling arrow. I'll just use the same thing, just so you can remember that's going to be that. So that means I got an A. My inequality has changed the other way, and I got myself a negative 8. Again, can you graph it? Then can you put it into interval notation? Cool. Alright, graphing it, negative 8. Again, closed dot this time, going off to the left. We're good there with the graph? Has to be closed dot because of the little equal to part over here. And again, going off forever, so that means it's negative infinity to a negative 8 with a bracket.
Wait, why did the sign switch?
Because we divided through by a negative number. So because
so if
that
you're
negative.
dividing by a number, then it switches over.
Dividing or multiplying by a negative.
Oh.
That little negative concept.
Oh, okay.
So here we divided through by a positive, and that was still okay. Nothing switched.
Would there ever be a bracket on the left?
On here, infinity symbols, they always have parentheses next to them because you can never get to that smallest number in the world.
No, but I mean, will there ever be one on the, like, is it 5 in infinity?
Yeah, if right here, if this was a closed dot right here, then there would have been a bracket at 5. Yeah. So the parenthesis and the bracket is all determined by closed dot or open dot. That's all they're determined by. All right, and of course, we've got to put in some fractions and some decimals. Can't have algebra without fractions and decimals. All right, and if you want to stay ahead of me, go for it. All right, if you want to work with me, let's do it together here. Let's see. So negative x over 3 is less than 6. In order to get rid of the negative and the 3, how about if we multiply both sides by negative 3? I have to sort of squeeze in the negative 3 in front of the 6 here. Okay, everybody good there?
Mm-hmm.
Let's see. First of all, the negatives go away, and the 3's go away. So x is left by itself, and we have to switch our inequality, right? Because we just multiplied through by a negative number. So x is now greater than negative 18. All right, graphing it. Looks like this here on the bottom here, negative 18. Open or close that? Open, left or right?
Right.
One of them, yes, one of them. To the right. And let's see, can we write an interval notation? So we've got parentheses, negative 18, comma, infinity. Okay, number 6, there's really two different ways to do number 6. You can either keep the decimals in there, or you can get rid of the decimals. What do you guys prefer? I prefer getting rid of the decimals, because I don't have to deal with them here. So 4.6, 5.7, notice I would have to move the decimal once here, once there, and then one more time here. So technically I need to move it all once each time. Alright, moving a decimal is really the same thing as multiplying by powers of 10. So if you move the decimal once, you're technically multiplying by 10. If you move the decimal twice, you're multiplying by 100. So technically what I'm going to do, on this side I'm going to multiply by 10. On this side I'm going to multiply by 10. So I'm left with 46x minus 57 less than negative 39x plus 113. Cool. Then from there, I can work with it. Let's see, I'm going to add 39x to both sides. Cancels there. This gives me an 85x minus 57 greater than 113. Don't have to move anything here over. This becomes 170. Ooh, divide by 85. Okay, some big numbers here. So 85 goes into 170. Oh, that's right, huh? Twice, because 80 is 160, so 5 more 170. Perfect. Okay, so final answer, x is less than 2. So if I have a 2 here, call myself an open dot, is that right? And it goes off to the left. Alright, make the arrow big because it keeps on going and going. And then can you write down the interval notation for it? Alright, so it looks like negative infinity, right, because it goes off from the left. Negative infinity all the way up to 2 and a parenthesis. Alright, next 2 just gets a little bit more complicated, not by much. Got some distributive property to deal with, and I'll let you guys try it yourself first. Alright. 9 halves, I believe. Let's go for it here. So distributing the 6 times x, 6 times a minus 5 makes 6x minus 30. Adding 30 to both sides, will that work? I got a 6x still greater than or equal to 27, dividing both sides by 6, and I can reduce that by 3, because 3 goes in both of those guys. So how about a 9 over 2? And the book, again, prefers it to keep it that way. Don't change it to a mixed number if there's no need to. And the only time we change it to a mixed number is if we need to graph it. That's about it. On usually X and Y grid, really. But 9 halves, what the book does, it just sort of labels wherever 9 halves would be. It's kind of nice. You just get to label. Yep. The previous textbooks we had, you actually had to put in integers, and then you had to put in where 9 halves would be in between integers. That was a little more difficult. Your book's a little nicer to you. So, closed dot, is that good enough to the right? And can you give me the final answer in interval notation? Perfect. Good job. All right, number 8. Again, just a little bit more complicated distributive property and some simplifying first. Multiplying by 3, or distributing the 3, first of all. And again, just checking your answers here. 6 and 5, that's the only ones that we actually put together, so it makes a negative 12x plus 11 on the left-hand side. At this point, there's 4 different ways to solve this, just depending which one you want to move across onto which side. Cool? But most of the time, I think you'll probably do negative, the 4x gets moved, gets you a negative 16x. Subtracting the 11 gets you a negative 4. Here it is, dividing through by a negative 16 on both sides and reducing by 4. Everybody okay there? And again, even if you went a different direction, that's still fine, as long as you got to x greater than 1/4. And anybody did it a different way? Did you add 12x instead? Yep, okay. Let me show you that, because that is a common thing that students do right here. Let me go a little higher here. So instead of subtracting the 4x, just going to show you how this is going to work out. That's a 7. Some students, what they'll do is they'll add the 12x, so they don't have to deal with negatives at all, and that's fine too. You get 11 here. That's 16x over here, and then notice what's going to happen here. Subtract 7 from 11 gets you a 4. Divide through by 16. Notice I'm dividing through by a positive, right? And I still get to reduce by 4. So notice what I got here. I got 1/4 is less than x. And here's what I really want to show you this here. This is important. Notice your variables on this side. So if I were going to switch the x and the 1/4, I want the x on this side. I want the 1/4 on this side. When I do this, I have to switch my inequality as well. We good? So there's really 3 different reasons why we switch. Right? Multiply through by a negative, divide through by a negative, or we switch the sides of an inequality. Okay, where does this come from real quickly here? From pre-algebra? Everything comes from pre-algebra. 3 is less than 5, is that right? If I switch them around, do I have to switch the inequality? Absolutely, right? If the 5 goes first, now it still has to be pointing towards, or opening up towards the bigger number. Okay, good there? Okay, finishing this off, let's go for it here. The graph of it goes like this. 0 marker if you want to, but 1/4 here, open dot. And how about going off to the right? All right, final answer. Parentheses, yep. Awesome, cool, and there it is. There's the finished product.
Did that graph work for both?
Yes.
So that's gonna be the same picture for however way you solve that problem?
Yeah, because eventually here at the end, the question is this going to work for both sides? Yes, because eventually you're still going to have to do this. You're still going to have to put the variable first and seeing how it compares to the number. At that point, then you got the same exact answer. Okay. All right, this one's, now we get to the formulas. Uh-oh. Now I have an x and a y. And I'm going to have to solve for the y value. So this is kind of like the 2.5 formulas, but now with inequalities here. Let's go for it together. Looking at this here, I'm going to try to solve for y. Y is over here. So I'm going to try to get this guy by itself. So let's get rid of the 3x first. So subtract 3x here, subtract 3x on this side. So on the left-hand side, I'm left with the negative 4y. Again, symbols exactly the same. And I like to put the one with the x first. Okay, and how should I put this here? For the book, you have to get rid of this negative 4, right? So we're going to have to technically divide through by negative 4. You can divide this whole entire piece by negative 4, but what the book does, it individualizes each of these pieces. Why they do that, I don't know, but they always do that. Just to make it a little more simpler form, that's all. Okay, my first question to you, do we have to switch our inequality?
Yes.
Absolutely. So y here, that gets switched to a greater than symbol. 4 doesn't go to 3, but I can make it positive. And see, positive 24 divided by negative, positive 24 divided by negative 4. So negative 6 or a minus 6 as our final answer. Alright, and of course, number 10, the trickiest problem here. So I got the sum of 2 consecutive odd integers. Again, that consecutive odd stuff. Sum of 2 consecutive odd integers is at most 46. What are the possibilities for the first of the 2 integers? Whoa, this is going to be fun. So first of all, what is x? I guess x will be the first odd integer. Again, you could put first number, you could put first integer, whatever you want. This is probably more descriptive here. All right, if that's the first one, what's going to be the next one? X plus 2, you got it. Second odd integer. Alright, so now when you say is at most, what symbol is at most? Yeah, it's less than or equal to, right? It's going up to that point, but then it can't go any further, right? So how about x and x plus 2 can be added up, but it has to be less than or equal to 46. Alright, dropping the parentheses here. With nothing to distribute and adding the x's together. Okay with, are we okay with 2x plus 2? Let's see, subtracting 2 from both sides gets you 2x is less than or equal to 44. Dividing by 2 gets you x less than or equal to 22. I'm going to wait for your answer. What do you think the answer is? So let's see. What are the possibilities for the first of the two integers?
Sorry, they have to be odd.
Say again?
They have to be odd.
Mm-hmm. I go with that.
I'm confused because of the line number 1.
At most,
So let's go.
23 equals 44.
Well, let's see.
oh, okay.
The number itself has to be less than or equal to 22, right? Can't use 22 because it's even. So as we step down, the next one would be 21, right? So at most, that should be a 21, right? Because 21 plus 23 would give you 44.
Yeah.
But if you go 23 and 25, that's going to give you 48 already. That's too
Yeah.
much, right? So then the highest first integer can only be a 21.
You're supposed to find both or just the one?
Just one. What are the possibilities?
Oh.
What are the possibilities for the first of the two integers?
Oh.
All right, and with that we say chapter 2 is done.